This week, I would like to finish off the remaining two topics of classes and objects. The first topic will be static variables, and the second one will be helper methods. So static variables are a way for you to declare global instance independent variable. There's only a single copy to be shared by all instances of a particular class. That's something we'll see, some useful application where you can use static variables. Let's start by considering some motivating scenario and see how we can apply static variables. Before that, let's appreciate what if without static variables, what would the code look like. Let's now switch to iPad and consider this particular example here. Let's say we have one template or class for bank accounts, and we got two private attributes. We got integer ID. So we're making the assumption that every account ID contains numerical digits only. And also we got string owner, basically the name of the owner. And we have to provide public access to the attributes. So we got get ID. You can also define get owner if you wish, but for our discussion, it's not necessary. And we got a public constructor, which will be used to initialize the ID and also owner. And because of a variable shadowing, as we spoke about before, you must use the this keyword to disambiguate about your use of ID attributes as opposed to ID parameter, right? All right, so that's about the simple class we have. And let's now see some tester. I just use some tester over here. You can definitely declare some main method or maybe use some JUnit test, either way, okay? But for now, I'll simply just do code tracing over here quickly. Let's say we got the first one, we want to create EECS1022 as account objects over here. And that one there is going to store the address of this particular account. And notice that we must pass explicitly the first parameter is expecting some ID integer. So I'm passing 1 over here. 1 has not been used just yet, so I can use 1. Okay, let me just visualize what's happening over here. So what's going to happen is EECS1022 stores the address of some account objects. And what should be the structure for each account objects? We got two attributes, ID and owner. So I would say account objects, and also we got ID and also we got owner. So I would say ID and also O for short for owner. And then ID in this case will be just 1. And then Jim is going to be a reference type, so that's why it will the owner field is going to store the address of some string objects for Jim. Okay, so that's the first objects. Let's now see the second one. So we also got EECS2 over here, right? So you will just be a brand new account objects, and now notice that we have to deliberately choose some unique ID because 1 has been used already previously. So we're going to choose 2. So now EECS2 stores the address of another account objects with the identical structure. So there would be account. And then we got two attributes, the same as before. So we got ID and also we got owner. And the ID will just be 2. And also the owner will be Jeremy. So the owner field stores the address of another string, Jeremy. Okay, and the most critical property about assigning IDs to the bank account would be you want to make sure the ID fields over here are simply unique, so they don't really duplicate each other. So let's take a look. So now we are trying to get access to the ID. So you can see we got EECS1 as a context object, and also we got EECS2 as the context object over here. And what will be the ID? You can see very easily. EECS1.getID, EECS1.getID is going to be 1, right? So this will give you 1. And then EECS2.getID, so the context object is different, so EECS2.getID is going to give you 2. So we get 2 here. It's very easy to see that they are not equal to each other. So this is good because now we can be sure for the accounts we have created so far, they got unique ID. So what could be the let me say this. So far, everything is working. Nothing wrong. However, let me go back to the slides to tell you the conclusion for this motivating example. Managing the unique IDs manually is error prone. For example, you can see here, in order for me to create these two account objects, I have to come up with two unique integers, 1 and 2. And imagine a realistic bank account system. If every time I need to every time whenever I want to create a new account object, I need to, number one, look back to see what IDs I have used so far. And then number two, to use just another number that has not been used before as the ID for the new account objects. It's going to be error prone, because if this process has to be done manually by a human or by the programmer, it would be hard to check, right? So that's why we have to really aim for another way that that should be as automated as possible. So this is why we want to use the so-called static variables to really manage the IDs automatically. All right. So that would be the motivating scenario. So when should you use a static variables? I would say whenever you want to have some unique or maybe have some one single copy of some global value that will be shared by all the instances of a particular class. In that case, you ought to use static variables. You can see over here, we got ID here, we got ID over here. However, 1 and 2 over here they do not seem to be related to each other in some way. But once we use the static variable, you will see the way we generate them will be somehow similar, and so that's why they're somehow related, and therefore we can guarantee you always generates unique IDs. That's something we'll see. All right. Before I show you the ultimate solution that we will definitely study in detail, I would like to show you some ideas about how to use static variables using some simple example. Let's do that. Okay. So that's something I'd like to show you over here. Let's now go over these two classes, and if you have already downloaded your weekly lecture Eclipse projects, you can see under lecture number 4 and under static variables, you will see the counter and counter tester. So these are the two classes I'm illustrating right now. Okay, you can take a look. All right, let's now understand the structure over here. Let's start with the left hand side. We got some counter over here, and then we'll try to run some easy test, simple test on using some console application counter tester. Okay, you can see here we are basically using private integer L standing for local. Okay, so this is a private attributes, which is something we have seen before. There should be no surprise to you. And then this one here is interesting. We're using static int G, and then is also assigned initialized to be 0. You can see several new items already. You can see if you look at this line here. First of all, we are using this keyword static, and number 2, the advice I gave to you in the weekly number 8 Java tutorial was, whenever you're trying to declare attributes, you should only put decorations. For example, like the L over here, you only put a decoration and leave the initialization for the attributes in the constructor. That's basically my advice. However, for static variables, given their global nature, you can initialize them right away. Okay, so that's the difference. The reason that I initialize it is actually appropriate because it's actually static. Okay, so notice that, right? So you should really say this part over here, this is the initialization. Okay, and you should really now see the syntactic difference. One is integer L. The other one is static int, right? Let me just say it again. You say int over here versus static int. So these are that's the difference. One is a static integer, and the other one is non-static. That's what we call. Let me explain quickly about how you should understand between the two. Okay. So we are basically comparing two kinds of variables. So one is about non-static variables, and another one will be static variables. For non-static variables, you can see this is actually the example we did, right? It's the integer L. Okay. For example, if you simply in the at the class level, if you say integer L, okay, so this is also so-called attributes. Okay, and then it's really important to say that they are instance specific. Meaning that each objects of the class, and when I say the class, it is the class where the non-static variable is actually declared, the attribute was declared. You can see here, I got L here, so any objects instantiated from counter is going to have some instance specific value for L. Okay. Each object of the class has its own copy. Okay, and let's visualize very quickly. So let's say here I might got one counter called C1. Okay, let's say we got some counter objects over here, and then each counter has a local value for L, and also we got another counter object called C2 over here. And then let me just draw better, and just another counter objects, and you got another copy for L. You can see here, this copy here and this copy here, they are two separate copies, as if you declare two separate variables, right? Conceptually. Okay, so each object has its own copy. It's really important to say that. Okay, and let's now make a contrast about static variables. And the example I made was static int G, standing for global, right? So you would say integer. Oh, sorry. I was first of all say static and also integer, for example, G. So this will be the example we are going through. And again, static versus when you don't declare static, so that means it is non-static, right? Number one. And number two, typically you will actually put the initialization for the static variables right away, because you only try to initialize the non-static variables or attributes in the constructor. That's what you would do. Okay, so you initialized in constructor. Let me try to move the words a little bit so I can make a little bit more space for myself. Okay, let's say that. Oops. Okay, that's good. Okay, so initialize in constructors. Let's now see what the corresponding points would be for static variables. So we don't really call them attributes, so for that part you pretty much can understand. So what about the contrast to this particular point? So that will be instance independence. Instance independence. So here I meant by two important observation. Number one, all objects of the class share the same copy. Share the same copy of this particular variable. So you can think about, in order to for me to visualize it, you can think about the G is simply just somewhere global, and G is simply you can think about I just simply got a box for G, and then the value over here initially will just be, for example, initialized to be 0, right? So the value will be 0. So this particular G is visible to both C1 and also C2, right? And whenever you're trying to change the value of G from 0 to something else, it's going to be visible to both objects. But we'll illustrate that in a moment. Okay, so that's point number one. So there's only one single copy. And number two, to access it, class name is suffices. For example, if I want to get access to this particular static variable g, I can just use the class name. You can see it's declared under counter over here. So I can simply just say counter.g. And you might find some familiarity over here. Remember, when you actually call your utility method in the beginning of your labs, in that case, you can simply say utilities dot some method, right? Similar, because we declare this particular variable to be static. So that means you can simply use the class dot variable name. So that's something to note. Okay, it would be okay if you say c1.g and c2.g. However, Eclipse, as I will show you, is going to give you some warning, but I will show you that in just a moment. Okay, let's now make a little bit more organized for the notes. You can see 1 over here is contrasting to this 1 over here, right? So we basically got a point here. We say that own copy for each object versus share the same copy. That's a contrast, right? What about for point number 2? For point number 2, what would it take for you to really get access to some particular attributes? You need to create some context objects, right? To access it, a context objects. Right? We speak about context object for sure. You know, since we introduced you to OOP, is necessary. For example, if I want to get access to L, I should really ask you which L do you want to get access to. Do you want to get to the L for C1, or do you want to get to the L for C2? So in this case, it will be mandatory for you to say maybe C1.L conceptually. Of course, in your Java code, you cannot simply just write C1.L because L is private. I'm just saying conceptually. Okay, of course, you're going to say C1.getL. In that case, that will return the L over here. Okay, similarly, you can say C2.getL, which will give you this separate copy instead. All right, so that's about the important differences between static versus non-static. You want to make sure you understand this first. Okay, let me recap very quickly. When we talk about syntactic difference between the two, so one would be static, the other one without any static, it would be non-static. Okay, and for non-static variables, it's going to be a separate copy between each object, separate copy. And for static variables, it's going to be a shared copy G over here. So it's shared by all the instances of this particular class counter. Okay, and then in order for you to get access to the variables, in the case of non-static variables, because it's instance specific, you ought to know which instance you're talking about, the context object. So you're going to say c1.l. You have to create this context object first. On the other hand, for static variables, since it's actually shared by all the instances, in that case, it would be okay if you say c1.g or c2.g. However, it wouldn't be so necessary to do so, because when you say c1.g, you're saying that I want to get a g specific to c1. That doesn't make sense because c1 does not own just g. G is actually shared by c1 and c2, all the existing instances of the same class. So that is why you can simply get access to g just by writing the class name, right? It's a very important conceptual difference between the two. Having said this, let's now complete this particular example about counter. Okay. All right. Again, we got integer L, non-static. We got static integer G, so that's static, and then we got some initialization, right? And also, of course, the difference between these two, another one is for you to initialize the non-static variables, you should do them in constructor. What about for static variables? Okay, I'll put it here. They should be initialized upon declaration. Right? You can see that as soon as we declare that, we're going to say it's assigned to 0, initialized to be 0 right away. All right. Okay, we got L, we got G over here, and then we got some constructor. You can see the constructor only initializes the non-static variables. It's really important for you to see that, right? So this will be the initialization of non-static variable or the attributes. And let's talk about one accessor that's public, so we can simply get a local variable. So this is what we have done before. And also we can say increment local and also increment global, right? When I say increment local, I simply say context object.l. So this will be, you can think about this is the L specific to the context objects. For example, if I say C1.increment local, in that case, I'm really talking about to modify L for C1. If I say C2.increment local, I'm going to modify L for C2 for sure, right? On the other hand, if you look at this particular mutator, increment global over here, I simply say G++. If you say this dot G++, it will be compilable. However, there will be some warning, which I'll just show you very shortly. Okay, so you can think about here this particular update G++. So that's the G shared by all counter instances. And of course, when I say instances, I meant objects as well. All right, so that's about the explanation for this particular class, right? With the two variables, one static, the other one non-static. Let's see how we can do counter test over here, and then I'm going to initialize. I'm going to visualize as well. Okay. Let's start with over here. So we got C1, and also we got C2. Okay. So what we have is, you can see C1 stores the address of some counter objects. And what should be the structure for the counter? It should be all the non-static variables, in which case just L. Okay, and the default value would just be 0, right? You can see we initialize that to be 0 explicitly. And then we got C2 over here. So C2 stores the address of another counter objects. And then you also got L, right? And then in this case, it will also be initialized to be 0, right? So that's about these two lines. You might be wondering, what about the static variables? The truth is, even before these two objects were created, the static variable G is already available, which I will illustrate to you in Eclipse. Let me just finish the illustration on the paper quickly. I can say even before this point over here, the static variable is already available. Okay, static G already available. And I would suggest the way to visualize it, you can simply just draw some box over here, like a placeholder, and simply just put the name G over here. And then it's initialized to be 0, so I'll put 0 over here. You can see the G here is not part of C1, it's not part of C2 either. It's actually standalone to be shared by all the instances for the counter. There might be C3, C4, C5 later. Let's now try to go over the code quickly. Let's say this. First of all, let's now do this. What if I say C1.getLocal, right? So C1 is this object here. The local will be 0. C2.getLocal, the context object will be C2. Local will be 0 as well. Easy so far. And then when we say C1.g and also C2.g, notice that here you don't see any yellow underline as warning because I already turned them off when I do the screenshots. But I will show you that in the Eclipse. C1, C2 will be the global value for G. Over here, they will just be 0. However, let me highlight it to say that C1.g and also C2.g. We should really say that for these two over here, use of a context objects to access a static variable is unnecessary. It's really important for you to know that, right? That's why I'm writing that down explicitly. You can see C1 is a context object and G is actually static over here. So that's why C1.G will work, but it's not necessary. And also C2.G is not necessary either. So what would be enough would be, you can simply say counter.G. So this will be the way to get access to the static variable. You can see we don't need to create here, let's say this, I will put it over here, access to static variables does not require a context object, right? Okay, good. Let's now do a little bit updates over here. When I say here, when I say C1.increment local, right? So now I'm going to execute increment local over here, and this will just be C1. C1.L, C1.L plus plus. So that means it's going to increment the value for L over here by 1. So that will be 1 after this particular updates. Hopefully you can see so far. And then I'm going to say C2.increment local. So I'm going to execute this method again, and then this will be replaced by C2. So C2.L plus plus. So C2.L plus plus. So I'm going to update this value over here. So that means rather than 0, it's going to be incremented from 0 to 1, right? And now let's take a look at the next two lines, which will be interesting. In the next two lines, we are saying C1.increments global, right? So here, what I'm doing is, I'm simply call this mutated method here, increment global, and then even though C1 is a context object, but it would not be so necessary. But you can think about the implicit this is really being replaced by C1. So you're really saying C1.G plus plus. So C1 dot here, there's really no G specifically, but you can think about C1 when you say C1.G, you're really referring to the G that's actually global over here, right? So what you're doing is C1.increment global is going to say G plus plus, right? So G plus plus is going to increment that from 0 to 1. So that's the first one, right? Let's do another one. What about C2.increment global, right? We're still going to execute this method here, and then we'll still say G plus plus. What that will do is it's going to increments from 1 to 2 over here. Another way for you to do it, which is more appropriate, which is to say counter.G is assigned to counter.G plus 1, right? You can see this will be the access to the static variables without the use of a context objects. So counter.G is again referring to this G over here. And then we're saying that it's going to be its own value right now, which is 2 plus 1, which will be 3. So we'll update that to 3. All right, so that's about a simple tracing. The tracing for the simple programs, but it's really important for you to review all the specifics which I have written down for you, right? It's really important for you to see that. Let me show you very quickly about how to run this program in Eclipse. Let me point to you some important stuff, and then we're done for this video, and then we'll continue to really go over the solution for managing the account ID automatically using static variables. That's what we'll see. But let's now switch back to Eclipse. Okay, let's go back here. And what I would like to show to you is if I go to counter over here, you can see here we got G plus plus, right? So you can see G is the static variables. However, if I say this .G over here, you will see it will compile, no syntax, no compilation error. However, there's a warning over here. If you put your move your cursor over, it has the warning message. Let's read it together. The static field counter.G should be accessed in a static way. So when you say this.G, it's not read. Okay, so this is a warning. G is not static. G is not accessed in a static way. It might sound a little bit funny when you say comments like this, but when a static variable should be accessed in a static way, so that means you should only use counter.g, for example. So that would be a static way to say counter.g, right? But I'll just leave this this comment over here to remind you. Okay, so that'll be one example I would like to show you the warning. If you go to counter tester over here, so you can see C1 dot get local, C2 dot get local, they are fine. But now when you say C1.g and C2.g over here, C1 is a context object that's been created previously over here, and also C2 was also created as a separate context object. But now if you say C1.g, C2.g, again, we are not accessing the static g in a static way, right? If you move your mouse over, it's going to say the static field counter.g should be accessed in a static way, meaning that you should only say counter.g, right? You should really try to avoid to say context objects dot static variable name. That's what you should avoid, even though it wouldn't be a compilation error, but conceptually that's not exactly right. All right, and I would like to just show to you how to run the debugger very quickly. Okay, I already put a breakpoint at line number 6. If you can put it right in the beginning of the console tester, okay, the counter tester. If I launch the debugger and switch to the debug perspective, so now I'm in line number 6. Okay, let me remove the previous expressions. Okay, and let's go to variables. You can see right now we are now right before executing line number 6, right before we even create C1. So that's why under variables you don't see C1 or C2. That makes sense. However, as I said before in the iPad notes, I said even before these two object creation, static G already is available. Let's see how so. Apparently, I cannot say C1 and C2, they simply don't exist. If I say C1, it's error. They don't. It doesn't exist. If I say C2, it doesn't exist. However, if I similarly, if I say C1.g, also it will be error. C1 doesn't even exist, right? And also C2.g also doesn't exist. Notice that it's not even like a null pointer exception, because at this point over here, we are now right before even declaring C1. So that's why it's simply just error. Okay. However, now if I say counter.g, it is available, right? It's the global one. So you should think about this global variable here exists even before you create the very first instance of your counter class, right? So that's why we should really put the initialization not in the constructor so late. We should really initialize the static variable to some proper value even before the very first objects for the counter class is created. So that's the rationale, basically. All right, let's go back here. And then if I just step over, you can see, so now we got C1 and C2. So now it would be okay for you to say C1.g and C2.g, but it's not really recommended. You're not really accessing G in a static way. It should be counter.g. And the most important thing is, before line number 6, at the very beginning of line number 6, we actually got counter.g already working. All right, that's the most critical point. Right, for the rest, it will be just up to you to really go over line by line and try to check it out. I also put more comments over here to actually guide you through this particular example. All right, so we're going to end the current video by recapping very quickly. We spoke about syntactically how you can declare static variable. Oh, that's the solution, which I'm going to show next slide. But it's mainly this page over here. You want to know about how to declare static and how to know a particular variable is non-static. And then to know that what does it really mean to access a static variable in a static way. And also you should know how to visualize the static variable by drawing that not part of any object instance like this, right? And also review the written notes which I summarize over here. So that'll be very important in order for you to appreciate the solution which we're going to present in the next video.